Okay, so tonight I asked you to do some of these reactions, and some of them have products and some of them don't. So this first one does have, the reactants and the products. And if you look on your ChemCruncher, you'll see that this is ammonia, which is NH3. And that's combined with iodine, which is I, but I is diatomic. So don't forget to check to make sure that these are diatomic or not. To form nitrogen triiodide, which is Ni3. And hydrogen gas, and again, hydrogen is diatomic. You don't have to know whether these are gas or any of those kinds of things. So if I write that out, and then I let my triangle be an N, let's make a circle be an H, and let's make a square be an I, then I have a triangle O, 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 and I've got I2, which is going to be a square, square. And that's on the left side of this reaction. And on the right side is going to be a triangle with 3 squares. And H2 will be 2 circles. So now I check and see, okay, well, I've got 3 circles on the left side, but only 2 circles on the right side. So I got to fix that. 1 triangle and 1 triangle, and then I've got 2 squares and 3 squares. So in order to get the 3 and 2 to balance, I need to go ahead and add 2 more of these, because that's a 6, which is a multiple of 3, which means that I still need another one of those. And now I got 2 triangles. So now I've got to go ahead and add another triangle, but in order to do that, I can't just add a triangle. I've got to add a triangle with 3 squares. Now I've got 6 squares, which means this needs to be 6 as well. And so I need, if I'm looking at these pictures, I need 2 of these for every 3 of these to make 2 of these and 3 of these. And if I want to check my answer, if I want to check my answer, I can go ahead and just line this up. I've got an N, an H, and an I. There's 2 N's on the left side and 2 N's on the right side. There are 6 H's on the left and 6 H's on the right, and 6 I's on the left and 6 I's on the left. And so we have a beautiful balanced reaction. Let's try number 2. So we got combustion of propane. We're going C3H8. Plus O2, and that goes to CO2 and H2O. I'm going to skip drawing this one just because I don't want to draw every single one of these. I'll throw a 4 out here to balance the H's, and I'll throw a 3 over here to balance the C's, and now I end up with 3 times 2 is 6 O's, plus 4 O's is a total of 10 O's, and so I need a 5 out here, and that should balance everybody nicely. The next one says that we have the incomplete combustion of propane, so you got to look up what propane is, and that is C3H8. And again, I wouldn't expect you to know that. And it says that it's an incomplete combustion, so instead of forming CO2, this is forming CO and H2O. So again, I'm not going to draw this one. So this one is a 3, and we've got a 4, and so we've got 7. Uh-oh. So that means that this needs to be 3.5, but we can't have a half. So I need to rewrite this reaction, multiply everybody by 2, because these are just multiples. Okay, so now all I did was I took this 1 and I multiplied it by 2. So if you think about it as a for every statement, if I multiply this one by 2, that means I got to multiply this one by 2, this one by 2, and oops, look at that, a good thing I checked. I need to multiply that one by 2 as well. Okay, and the reason I did that was because I can't have half of a particle of O2. Oops. The next one says that I have nitric acid and potassium hydroxide. And again, you might have to look this up. It's also on your ChemCruncher. Nitric acid is HNO3 and potassium hydroxide. Now, on tomorrow's quiz, I won't expect you to know how to guess what the products are. So this would form potassium. You should be able to recognize that this is going to be a double replacement reaction because I got a metal, a non-metal, and a non-metal. So the K and the H are just going to switch spots, but they do it based on charge. So K plus goes with NO3 minus, and it does it in a 1-to-1 fashion. Plus, and H plus goes with OH minus, and again, because they're 1-to-1 already, I don't have to mess around with those. It's going to form water, and this one is actually balanced just the way that it is. So if I were to draw this all out, we'd be all set. You're going to draw it just to make sure. So the reaction of copper 2 oxide, so again, remember that copper 2 means Cu plus 2, and oxygen is a -2, so that's going to be CuO. Plus hydrogen, well, hydrogen, remember, is diatomic, to form copper metal and water. And if I were to draw this all out, I'd make Cu a triangle, make O an O, and make H a star. Then we'd have triangle O. I'll make them touch. And I've got star, star. And on the left side, on the right side of the reaction, I've got triangle, O, and 2 stars on both sides. Okay, so I've got 2 stars, a circle, and a triangle on both sides, already balanced. Didn't need to do anything. The reaction of iron metal, Fe, plus oxygen, which is O2, to form Fe, which is a +3, and O, which is a -2. So again, I need 2 of these to make a +6, and 3 of the -2s to balance out. So this is Fe2O3. Let me erase this, and let's draw this one, just for fun. So I'm going to make Fe be a triangle. I'll make O be an O. And on the other side, I guess that's the only stuff we have. So I've got a triangle, and I've got an OO together. Whoop. And then I've got a triangle with an O, a triangle, an O, and I guess another O on there. So to get this balanced, well, it looks like I need another triangle to balance out the triangles. And then it looks like I got 2 and 3, so then I'm going to need, if I add another one of these, then I need 2 more of these to get the 6 O's. But now I've got 4 triangles, so I need 4 of these guys. So this is 4, 3, 2. And again, I can check my work by, oops. Underneath the arrow, I can just say FeO, and this is a 4. This is a 4, because 2 times 2 is 4. 3 times 2 is 6. 2 times 3 is 6. So now we have a beautiful reaction. Let me do the last few here. Okay, 2,2-dimethylpropane. Oh boy, that sounds like a lot. But it really just is C4H10 plus O2 goes to CO2 plus H2O. In order to balance this one, again, I'm going to just go ahead and, I'm not going to draw this one. I'll just go ahead and take inventory underneath. So CHO, this is 4, this is 1, this is 10, and this is 2, and the O's are going to be 2 and 3. So I would think the 4 and 1 is pretty easy to balance. So I'm going to go ahead and do that. That changes this to a 4, which means this is a 4, and the number of oxygens is 4 times 2 plus 1 is 9 oxygens. And then I need a 5 out in front here, which changes this to a 10, and changes the O's to 8 plus 5 is 13. So now everybody but oxygen is satisfied. And so again, this is another tricky one. This would have to be a 6.5, because in order to get 13, a multiple of 2 is not a whole number. So again, I cannot leave that a half. I'm going to have to do something a little different. So that would mean that I'm going to have to rewrite this. This would be 2 C4H10 plus 13 O2 goes to 8 CO2 and 10 H2O. And now again, I could take inventory and test it out. We won't do that here. And then again, the reaction of AlBr3 with magnesium hydroxide, MgOH2, you should, at this point, be able to recognize that as a double replacement reaction because I've got a metal here, and then I've got Br here and OH there. There's my two nonmetals. Okay? So these two guys are just going to switch spots. So now on this side, instead of Al plus 3 being with Br, now it's going to be with OH, which is a -1. And in order to balance that out, I'm going to need 3 OH minuses. And again, you don't have to do this on tomorrow's quiz, but you will have to do it next week. So this is going to be Al, OH, 3 plus, now I've got my Mg plus 2, and now that's going to be with Br -1, so I need 2 of those to balance that out. We've got Mg, Br2, and again, I would tell you that it's aluminum hydroxide and magnesium bromide, so don't freak out. Let's draw this out. So I've got an Al will make a square, Br is going to be a triangle, Mg will make a heart, and then OH we could combine together because the OH here stays in OH here. Or we could do O and H. But just for fun, I'll do OH together. So let's make OH be a circle. So this one I've got a square with 3 triangles. And then I've got a heart with 2 circles. And on the other side, I've got my aluminum, which is a square with 3 circles. And on the other side, I've got a heart and 2 triangles. All right. So now I look at this and I say, okay, hearts are good, squares are good, triangles and circles not so much. So I'm going to go ahead and throw a square down here and 3 circles. But if I do that, then I've got to make my circles be balanced. So 3 hearts, right? And now I've got my circles all balanced, but that means that this guy's got to have 3 hearts. And now I've got 6 triangles, which means I need another one of these guys. And I've got my 2 squares on the other side, so this is going to be 2, 3, 2, 3. Okay. Number 9 says the decomposition of hydrogen peroxide. And if you look on your sheet, it'll say hydrogen we should know is a +1. And O2 -2 is peroxide. So to get that -2 balanced out, I need 2 of the +1s. So this will be H2O2. And it's going to break down into water and oxygen. And let's make H be triangle and O be a circle, because that'll just make our lives easier. Triangle, circle, triangle, circle. And then on the other side, I've got triangle, circle, triangle. And O2 is just going to be those 2 together. Oh, I did a pretty bad job of making those together. Let's erase that up. So again, if they're touching, it means they're... Oh, it still didn't do very well. If they're touching, it means that they're bonded. Now I've got 3 O's on the right side and 2 O's only on the left side. Looks like my H's are pretty good. So I'm going to need to get a multiple of 3, right? Because there's 3 here. Well, maybe not. If I add another one of these guys, because the O's in 2 spots, now that's 4 triangles and 4 O's. And if I do a triangle, O, triangle, that looks pretty good. So this becomes 2, 2, 1. And just for kicks, let's go ahead and make sure that it's balanced. So that means I need an H and an O. This is 4 H's, 4 H's, 4 O's, and 2 times 1 plus 2 is 4 O's. And we have a beautiful reaction. And again, on this last one, This is ammonia with sulfuric acid. I would not expect you to be able to know what to do with this necessarily. This is going to form, and again, I wouldn't expect you to know how to do this, but this is going to form ammonium sulfate. So far so good. And if I look at this, that's 2 out in front here, I think. And you'll draw that all out and make sure. But there's your answer for that one. I hope that's been helpful. I don't want to make this too long. I know this is already 15 minutes plus. So if you got questions, let me know. Shoot me an email. But otherwise, this will be pretty much the math portion. And have a good night.